So we want to talk a little bit about responsive from a performance perspective today. Now, how many people are familiar with responsive design? How many people know it? Does anybody not know what responsive design is? And don't be shy. Nobody. Everybody knows. Okay, just in case there was anybody shy, just really high level, responsive design at its core is fluid layouts, percentage widths or something like that, fluid images, so images that scale, and media queries. That's generally what it's kind of composed of. It obviously gets much more complex than that, which is why everybody's here today. So when Ethan Marcotte wrote the post that first introduced everybody to responsive design, he closed the article by saying, now more than ever, we're designing work meant to be viewed along a gradient of different experiences. Responsive web design offers us a way forward, finally allowing us to design for the ebb and flow of things. And I've always been a very big fan of that gradient of different experiences, which I think we'll come back to in a little bit. And so when this first came out, everybody kind of latched onto this, right? Because we have all these different devices. We have to find a way to get our sites to work on these things, to display correctly. And it's kind of maddening. But at first, it was kind of adopted more for like blogs and content-heavy sites. And there was kind of this stigma that responsive design was, for those simple sites. It didn't really scale well to more complex sites. But that's kind of been blown away. You're seeing companies like Time and like Disney and Microsoft and I think CNN's got one that's coming out. I don't think they've actually got it launched yet. I mean, there's these big sites that are starting to do responsive design, and it's blown away this common criticism. So we're no longer pigeonholing this to something for personal blogs. And this is a great thing, right? Because as Ethan and John Alsop before him in A Tao of Web Design wrote, this is this inherent flexibility of the web. This is a benefit. This isn't something holding us back. This is something that we should be embracing for, this ability for the web to be interacted with on any number of devices and on any number of browsers with any number of input methods. This is like the superpower of the web. But there's more to it than layout. And you guys know that. I don't really have to tell. That's why you guys are at a performance conference. But a lot of the discussion about responsive design has focused primarily from this angle. Just how does it view on these different screens? How do we make it look? And that's kind of where it's gotten caught up. But when we go back to that gradient of different experiences phrase, he's hitting on much more than devices, much more than screen sizes. We're talking about gradients in terms of network capabilities, latency, bandwidth. We're talking about gradients in terms of hardware capabilities, CPU, memory, things like that. And those are the kinds of the bits of the flexibility of the web that I fear that we haven't quite given the same priority to when we're doing responsive work. Stephanie Rieger, who is she's brilliant, just an absolute brilliant mobile designer developer. She tweeted this at one point, that shoot me now, responsive design has become conflated with an opportunity to reduce performance. And I really, really wanted to disagree because I'm somebody who really loves performance. I'm also somebody who really loves responsive design. And I was like, my initial reaction was a very adverse reaction, like, no, no, no. But you know what? The evidence is kind of damning. Without naming names, these are 4 sites that launched within the last year that are responsive. These number of requests, 74, 114, 99, 105, this weight, this is on the small screen. This isn't a large screen. This isn't like the high-resolution cinema display experience. This is what you're seeing when you load these sites on a phone. These are fat sites. That's a lot of weight. And these sites, when they came out, they got praised a lot for their visual design and how they looked and the aesthetics and things like that, and rightfully so. I mean, they were beautiful, and there was a lot to be proud of in terms of what these teams pulled off. But these numbers are telling an inconvenient truth. For all the emphasis that we're spending on the visual design, that same attention hasn't been given to the performance. Now, Guy Pajarny did some analysis, and he wanted to look at responsive design and what the performance results were. So he analyzed 471 different responsive sites. And he found out that 72% of them had roughly the same size across all these different screen sizes. It means they're not really any smaller on the small screen, even though at the very minimum those images should be smaller because you've got 320 pixels or whatever it is compared to 1024, 1200. So you're not seeing much difference. In fact, he broke it down by the resolution, and you can see that there's not much happening here in terms of reducing the bytes that get sent down for these smaller displays. And these numbers are actually the page size per resolution is actually worse than the year before when he tested it. Sites are getting fatter and more bloated, which is a big issue. Everybody knows performance has been tied to just about every key performance indicator for a company. Revenue, traffic, conversions, everything. There's case studies demonstrating this stuff up the wazoo. And the expectation is that mobile is going to be just as fast. 71% of people want it to load as quickly or faster on their mobile phone than on their laptop, which is kind of insane when you think about it, right? Because, the idea that this is going to be just as fast as a souped-up MacBook Pro or something like that is kind of absurd, but that's the expectation. People aren't going to sit there and wait for this stuff to come. And when you boil it down, when you look at how performance impacts these metrics, when you look at what people's expectations are, you have to realize that performance is a fundamental component of the user experience. It's something that we have to put emphasis on. It's extremely important to every project. So why are we seeing so many bloated sites? Well, there's a lot of people who kind of come out and say that responsive design is just bad for performance. If you care about performance, you should not do responsive design. I was just talking to a company recently, and they wanted to do responsive design because they didn't want to deal with the separate code bases. They liked the potential it gave them in terms of hitting a wider range of devices because of its fluid nature. But there were people at the company pushing back against it, and the reason why they were pushing back is because they had heard that if they created a responsive site, they were going to make a very fat, slow site. My reaction to whenever somebody says that responsive is inherently bad for performance is something like this. I tend to disagree a little bit, and I also tend to abuse this GIF, by the way. If you guys, anybody Game of Thrones fans out there? Yeah, the kid is wrong. And I always laugh because there's always a couple people who have no idea what this is referring to, and they're like, you're showing a kid getting slapped. What is wrong with you? But guys, just watch one episode and you'll get it. One more time. All right. See, the problem is that we're blaming the technique. We should be blaming the implementation of it, not the actual technique itself. It's not something that's inherently bad with responsive design. There are complications, sure, but it's not a rule that responsive sites have to perform well. That's a cop-out. That's an excuse. It's if you give me tools, I'm really bad with tools, right? If you give me like wood and a hammer and some nails and you tell me to build something, what you're going to get is a pile of wood with little nail holes, a bunch of bent nails, and I'm probably going to have a thumb that's exploded from hitting it too many times with the hammer. That's not me. I'm not very good with those things. That doesn't mean that the hammer was to blame. It doesn't mean that the nails were bad. It doesn't mean that the wood wasn't something you could use, right? You give that same material to a carpenter, and they're going to create something that's going to last for a long time, something that's going to be beautiful. It's not the tools that were to blame. It's the fact that I just wasn't comfortable using them. And the other issue with this whole responsive design is bad for performance argument is it kind of falls flat on its face when you look at everything else. So in March 2012, we were looking at about the average site, according to the HTTP archive, being about 829K. March of 2013, 1031. Now, this isn't responsive specific. This is sites as a whole. So the web as a whole is getting fatter. The web is getting bloated. So it's not necessarily just responsive design where we have the issue. And to fix this, we need to stop making these excuses, and we need to start making these improvements instead. Now, before we get into the technical side of things, but we will get there, I want to start first by kind of attacking it from the perspective of more the culture and like the process early on. Because the more that I do this, the more that I find that this tends to be the issue 9 times out of 10. This kind of sets you up for an unsuccessful project throughout if performance isn't prioritized up front and early. I was talking to somebody about a responsive site that they had built, and it was well crafted. It was really well done. Actually, there was a lot of smart things going on. It was a little heavy, not like overly so, but just enough that he felt he needed to justify the situation a little bit. And he said, you know what, I doubt anyone really wants to make a site that doesn't perform well. It's just, a product of not being afforded the luxury of time and top-down pressure. And at first, this kind of feels a little bit like an excuse, kind of like a cop-out. But I don't know about you guys, but I can totally admit that I've been there. I've been on projects like this. I've been on projects where we didn't have the time to devote the resources to that for whatever reason. I should say the time wasn't dedicated to that. The time could have been there, but we chose to put it in other areas. I've been in places where that was not what was pressured. That when the top-down management was looking at it, Performance wasn't the first thing they were kind of, maybe they said they wanted a fast site, but that's not what they were really emphasizing when push came to shove. It was how were things looking and things like that. And that needs to change, because if that doesn't change, there are things in the design process and those upfront decisions that can kind of damn the performance of a project before you ever touch it in code. Now, there are ways around this. One of the things I like to do is to set a performance budget. This is something that, talking to Steve, that they did at Google. The idea is basically that you determine some sort of a budget, some sort of a baseline for your site, and then you ensure that those numbers don't get exceeded. So BBC did this with their responsive site. They decided that they needed to be usable, not necessarily fully loaded, but usable on a really poor mobile network in under 10 seconds, which sounds like a very high number, but they were talking about a very slow GPRS network with high latency. They were very much so talking about the lowest baseline here. Now, after testing, they found that that gave them about 65 to 100K, roughly in there, give or take, with requests kind of factoring in as well. But this gives them something tangible that they can then refer to now in the process. So now when they're making decisions about what goes onto a page and what doesn't, they have a framework to stand on from a performance perspective to make these kind of determinations. And it basically sets you up to do one of three things when you're talking about a new feature. So if you're going to add a new feature to this page, you can look at optimizing an existing feature. Maybe if they want to add a carousel to the page, you can optimize one of the scripts or something like that so that the size of that goes down. Maybe you can compress some images that weren't compressed. Whatever it is that lets you allow to stay underneath that budget. If you can't optimize anything enough to get that new feature onto the page, then maybe you can remove something. Maybe the carousel is more important than the big promotional banner that you have. Find what the trade-off might be there. And the third thing you can do is just don't add it, right? If it's not important enough to justify its existence on the site over something else, and if you can't optimize anything to make room for it, then maybe it doesn't need to be there. Now, this isn't the only way that you're determining what goes onto a page. This assumes you have a good strategy in place in terms of what content needs to be there. This is kind of helping you to tailor how you're displaying it and what features get in there. It's part of the equation, not the equation by itself. But without this there, you have nothing tangible to refer to. Every performance discussion becomes, well, if we add this to the page, it's going to slow it down. Okay, well, slow it down compared to what? Like, what's good enough for us? This gives you a good enough that you can point to. The other thing I think we need to do early on is kind of embrace that pain, channel our performance masochist, if you will. I think we all have a little inner performance masochist inside of us. That's why we're at a performance conference. I think a lot of the problem with web bloat is that we don't notice it as well. So a visual design comes along, and if somebody makes an ugly-looking design, you know right away by looking at that thing, look, man, Comic Sans and pink backgrounds with gradients isn't going to get it done. But we don't see those same glaringly, like performance issues aren't as glaringly obvious. We can be staring at a site that's 5, 6 megs, but if we're working on a nice computer and we're working on a high-speed network and that's what we're testing on and that's what we're developing on, we're going to be completely oblivious to the fact that this thing is going to be absolutely awful to use in the real world. It's easy for us. We live on the edge of Moore's law, so it's easy for us to kind of miss these things. But when you get out there, and a lot of people are using the lower-end devices. They're buying the cheaper devices. They're on devices that are 4 or 5 years old. They cling to those things. Those old Android phones, those 2.x Android phones. You can't pry that thing out of people's hands. In addition, you have some of the out-of-contract phones that you see sold, like the Net 10 and stuff like that. Those tend to be a few generations old as well. These less powerful devices aren't going anywhere. I live in the middle of nowhere in North Wisconsin. We are just now starting to get a little bit of 4G connection in spots. In other spots, you're still sitting on edge, not even 3G. You're sitting on edge. I feel this stuff very, very painfully. When I load up a site on these networks, right, it hurts. But it's not, yes, I'm kind of secluded out in the middle of nowhere, but I think that there's a lot of other people that have to go through the same sorts of issues. And those are the people that we kind of forget about sometimes because it's not so apparent to us that that's an issue. So we need to be able to, we need to embrace the pain. We need to feel this stuff early, and to do that, you need to get it into a browser and onto a real device as early as possible, because you can't find things in mockups. As Brad Frost says, you can't mock up performance in Photoshop. And how can you not trust a guy that looks like that? Yeah, he posted that on, I don't think he should have. He posted that publicly, and I'm using it from now on every time I talk about him. But he's got a point, right? I mean, you stare at the mock-up, you have no idea what the performance implications are, and none of us are that good. We're good, right? But to be able to stare at a mock-up and anticipate every single performance problem that's going to come up, it's not going to happen. You need to be able to get that into a browser and start playing with things. Even if it's not the full site, if for some reason your work process at where you are hasn't gotten to that point yet where you can get into it quickly, take a component that you think might be troublesome and put that component into the site and just see how that's handling on a browser. But spot these things as early as possible so you can do something about them before they're too late and they become requirements and they become something you have to have in there. One of the things, for simulating slow networks, there's 1,000,001 ways to do it. For one-offs, I love Charles Proxy. I'm addicted to this tool. You can very easily throttle. You can set the presets. You can record the traffic that's coming through. I mean, it doesn't have to be a very complex thing. Just experience what that's like. Charles Proxy. It works on both Windows and Mac. It's, I think, $50 or so. I don't think it's particularly expensive. You can also do a lot of things, from the terminal and whatever you're comfortable with. OS X 10.7 has network link conditioner right in it and things like that. So there are plenty of things you can do to do it. I just prefer the proxy tool for like one-offs so that I can analyze what's happening as well. Fiddler does it as well. Fiddler actually, it's historically Windows only, right? But I think that they have actually got a Mac version either out or in beta or something like that I saw. Is it out? It's running, yeah. So that's available too as an option. I think when I first got into it, I don't think it was there, so I think I kind of just fell into Charles. But basically just test it, experience it, and especially on those real devices, on real phones. If you grab one of those older phones and throw it up on something like that, one of those phones where you're got to tap like this to move things and stuff like that, experience that kind of pain before your users experience the pain. So now that we've got kind of a little bit of the process, I could talk about the process all day, but let's get into some responsive nuts and bolts. And we're going to start with images because, or why I cry myself to sleep every night, because responsive images are a huge, huge deal. And if there is only one thing that you do to get the page weight, the above the full time, the load time, only one thing you do, it should be the responsive images stuff. Here's why. This is the October 1st run of HTTP Archive. This is the graph. You probably can't see this stuff back there because of you might not even be able to see it here. Out of 1,590K, 970K of that is image weight. That's 61%. That's on the large screen. So let's look at mobile HTTP Archive. Here we've got 850K and 560K. We're at 66% on mobile is image weight. So images are kind of a big part of what that bloat is. Before we get into the issue of responsive images specifically, there's a few things you can do up front to kind of help yourself. The first thing is trim the fat off of these things. Compress any and all images you can. And it's amazing how often this isn't done. This is Newsweek, and I'm not poking fun at Newsweek. I actually think the Newsweek responsive site is beautiful. I think there's a lot of really great stuff about it. This is something that's common on a lot of sites, unfortunately. Before compression, for content images, they have 23 images on their page that weigh in at about 633K. It's a very visual design. After lossy or lossless compression, not even getting aggressive, just trimming stuff off that you can't tell any sort of visual difference, you can bring that down to 597.4K. So that's 35K. That's not a huge thing, but you know what? For 5 minutes of work, less than that if you're automating it, that's an okay savings. Now the CSS background images is where it gets interesting, because here they're using more of the pings and the GIFs and stuff like that. The content-based things are primarily these JPEGs and stuff like that. Before compression, 526K or so. After compression, 317K. Which means you save about 209K just by running these things through lossless compression. Nothing fancy. I put this in the deck after about 10 minutes of work, and that included the time it took to download all the images and then run them through something. Means on total, they could have saved 245K off their page weight just by doing this. Now this sounds really simple, and hopefully most of you guys are doing this, but what I'm finding online is that this low-hanging fruit is the stuff that often doesn't happen. And I think it's because a lot of times this is a manual process at certain places, which, anytime that you involve, Steve and I were just talking about this, anytime that you involve humans, well, I don't want to sound too harsh, but there's potential for failure. When you automate this stuff, when you make this just part of the process, I mean, you take all this weight off your shoulders. You don't have to worry about this. This can be easily incorporated into any sort of build tool so that this is just running, and this should happen. And again, this is just lossless. If you want to get really aggressive and start doing lossy, you can get far more significant savings off of these. Yeah.
Simpler imagery.
Well, is it because, so am I seeing the bigger things because there's simpler imagery? In some of the cases, yeah. So on the Newsweek CSS background images, a lot of the pings that they were outputting were fairly vector formats. They actually probably would have worked just fine as SVG or something like that. I'm not sure what their creation process was for getting those assets out. I like Adam Bradley. I don't think he's at this conference. He's been really into like the performance stuff, but I always liked what he said about save for web from Photoshop should no longer be in anybody's workflow anywhere. But if they were doing something like that, the Adobe products are notorious for spitting out these bloated images, and there's other software, graphics editing software that does the same thing. So depending on where the source of for those images, they could be starting off with this really big bloated thing. If you automate this stuff, there's all sorts of terminal tools. There's all sorts of things you can put into your build. If you prefer to work in a GUI thing, there's like Image Optum, Image Alpha, things like that are drag and drop interfaces that take care of this. But yeah, a lot of the times with these pings and these GIFs, they're very simple images, and they just have all this added bloat on top of them.
Does it turn out that a certain type of image format is responsible for more of this bloat that could be cleaned up, like are JPEGs triggering more bloat than GIFs and PNG, or?
So in my experience, in terms of just the lossless compression, like just taking it from this perspective, at this step, it's almost always the pings is what I find. And I don't know why exactly that is. I haven't dove into that enough, and I'm not an image optimization expert. But my experience has been that the pings are the worst culprits when it comes to this, for whatever reason. Actually, Sergey's... Yeah, well, the transparency is a big part of it. If there's transparency in there, yeah, I mean, it can be. But you know what? Even that doesn't have to be done. You can do that without getting all the artifacts and stuff, without losing that sort of performance. Sergey, you've done some image optimization things. So maybe, Sergey, if you raise your hand, he might be somebody you might be able to answer some of that stuff a little bit, I assume, because you've dug into that quite a bit.
Sometimes pings are huge because they are converted from basically misuse of the format. But there are other reasons for it.
Yeah. So they add a lot of fat unnecessarily. So trim it. If nothing else, start here because it's a very simple, it's not often that we get something that simple that can make a decent impact, but it can. Next up, show not, waste not. If you're not showing something on the screen, don't download it. Now this again sounds pretty simple, but it's kind of understanding what the browsers are doing here. On a lot of responsive sites, you just see display none thrown on top of a lot of things. It's useless, completely useless. It doesn't do anything other than hide it visually. You run a test like this, throw an image in the page, put a div around it. Everybody's going to download this anyway. I think Opera Mini and Opera Mobile were doing some smart things where they weren't downloading the image if the parent was displayed none, but I haven't checked that since they started getting into the whole blink thing, so I suspect that could have changed. But yeah, basically as a rule, just don't ever rely on this to do anything for you performance-wise. And it sounds simple, but again, this is like probably one of the most common things with responsive sites. What you can do if you're not going to be displaying these images is something, this is the BBC, this is a snapshot of their page. Now what they have is they have their primary image, and then they have all the way down, they have these newspaper articles and these summaries with little thumbnails. And they don't actually display these on all screens. So this is like their enhanced experience, and we'll get to this a little bit later. Their core experience doesn't have those little thumbnails in there. What they're doing is they've actually got these empty divs throughout. And the div has this class of I saw a little shift there. Has this class of delayed image load. So that's what they're using to be able to find this stuff through JavaScript. They have a data attribute that they're using to store the actual source of the image, what actually is going to get swapped into place. And then they store the width and the heights as well in data attributes. So then above certain screen sizes, or when they make that determination that these images come into play, they then pull these things in. So what this does is they don't have the extra weight that's sitting there on their core experience or whatever it is that doesn't have these images. They don't have to deal with the whole display none stuff. This stuff just isn't there. Now there's a catch here, and the catch here is the preloader, which is very, very important. Now, like back in the day, right, JavaScript will block so like a script would be downloaded and it would block everything else. It wouldn't try to make any requests in terms of like images, things like that. It was very bad. That's where the whole scripts to the bottom of the page thing kind of came out of that. This isn't the case anymore. So like in major browsers, what they'll do is they'll start to look forward now and see what other URLs they can start to request. What can they bring to what can they get a head start on in terms of images and things like that so that they don't have to worry about that. So that you get these performance gains. I think it's about 20% is what one study showed by Tony Gentlecore. It's a big, big deal. It's one of the biggest performance optimizations that the browser has made, at least in the last several years. So when we're doing something like this, when we're loading images in JavaScript, we're kind of breaking the preloader. The preloader doesn't have a chance to get those images and get those things, which slows down the rendering performance. So we always need to be careful of the trade-off here. That's one of the best parts, and I say best with a sort of a tongue-in-cheek. That's getting back to my masochist side. But it's one of the best parts about responsive performance is there's always going to be trade-offs because you're dealing with every screen and you're dealing with every browser and you're dealing with every network. So there has to be a balance here. One of the things that can help is to try and make a determination between what images in your page are decorative versus what of them are like hard set content. So if we go back to that BBC, they had the big image on top. That's a hard set content image. They made the decision that this thing was going to every experience. The little thumbnails, honestly, other than adding a little bit of eye candy, they weren't really doing anything. They were mostly decorative. If you think they were just basically augmenting the headline and the summary that sat next to them. So they made that determination that their content image, their primary image, the one that sat up top, they would have that thing as an image tag, so that the preloader could take advantage of it, get that downloading, get that up onto the page as soon as possible. And then on the more decorative images, that's where they would make those script determinations to be able to swap in and out when they wanted to. So if you can kind of break it down in that perspective, that can help sometimes. Now here's the fun stuff, is the appropriate images, making sure things are the right size and things are the right resolution. So shortly after Ethan wrote the article, Jason Grigsby wrote a post kind of calling out this responsive design thing back in 2010. This is 3 years ago. And one of the things he said was that the performance issues. The demo site had all these images. I think there were Sherlock characters. And Jason found out that if you actually resized those images instead of just serving them up and scaling them, you saved 78% of the image weight. And about then is when everybody started talking about responsive images and trying to find a solution. And we're 3 years in, and we still don't have one. What we have is a series of hacks, unfortunately, that all have trade-offs. And that led some people to get frustrated, because it is frustrating that 3 years we still haven't figured out how to do this. And a couple people started to write posts basically to the extent of they weren't going to deal with it until the browsers started to catch on. Like, maybe it's not even worth our time to try and go through these hacks and figure this all out. So I took Guy's list of 471 URLs, and I ran them through a tool called Sizer Soze. It's apparently a Usual Suspects reference. I have not seen the movie, and I had no idea the reference was there. How is it pronounced in the movie? Does anybody? Soze? Kaiser Soze? So it's Sizer Soze. All right. See, that's clever. That's clever. All right. that Yoav Weiss created. And it basically what that does is it looks at the site, it opens it up at these different sizes. You can set the different resolutions, and it checks to see what the images actually display at versus what they're sent. And then you can it resizes them and determines how much you would save at these different sizes. On average, and I know there's the, it really needs to be dissected from a median perspective as well, but on average it was 72% of the image weight was wasted on the small screen. That's what we were kind of setting down. And this falls right in line with what I'm typically seeing on most projects where we get to do some sort of responsive image solution. It tends to be somewhere between 60 to 75, 80% of the image weight from what the source is compared to what it actually needs to be is just wasted. So this alone is a big deal, right? I mean, this is a lot of bloat. This is a single optimization that can shrink the site, by a couple hundred K. That would be enough of a reason for why we need responsive images, but there's more. I was talking to Ilya, who's actually giving a presentation on networking tuning right now, I think, which if I get done in time, I'm going to cut out of this one and let somebody else finish and catch it. But I was talking to him about this, and he was talking about what this does from a memory perspective. So when an image is decoded in the browser, it basically gets stored off as RGBA values. So you have one of 255 values for red, green, blue, and alpha. Now, potentially the browser might try to make some optimizations here in the alpha thing. I'm not sure entirely, but this is the general gist here. So what this means is that when you've got a pixel in the browser, you're eating up about bytes of you're eating up some bytes of memory sitting here inside of the browser. You're eating about 4 bytes per pixel. So let's say that we have a 600 by 600 pixel image. And let's say we scale it only by 50 pixels to about 550. That's what we're going to display it at in the browser. What this means is that if we take the original size and what it was displayed at, we have 57,500 unnecessary pixels being stored inside there. That's quite a few bytes for just a 50 pixel to scale. Now imagine on these sites that are taking the 1200 pixel wide image and displaying it at like 200 pixels on the small screen, which happens all the time. You're talking a massive difference. So now we've got the memory plus we've got the size, but let's give one more piece of evidence here. This is a page where it's just a bunch of images. These are images that are appropriately sized for what they're going to display at. And you can see the scrolling behavior is fine. You can go nice and smooth. We've got it up to 120 images, no issues. This is in Firefox, by the way. This, however, is the large version of the image. Now let's pop this thing up to about, already you can see, and you might not be able to see because we'll show them side by side in a second, but you can see that it's a little bit more jagged as you scroll. It's not quite as smooth of a scroll. And if we put them side by side, I think hopefully it's a little bit more, it's not quite in sync, but it'll show you a little bit of the difference. We've got this nice, basically fluid scrolling going on here, a high frame per second. And over here, it's started to slow down for us on Firefox. Because what it's doing is it's trying to figure out all those different decodes and resizes and stuff like that. Now, Chrome, I didn't notice the issue on. But I talked to Jake 30 seconds before I was in here, Jake Archibald. And had I talked to him earlier, this would be in the deck. But it turns out that Chrome has this issue on Retina displays. I've been testing this off of the Air and off of a big monitor that's not a Retina display. On Retina displays, Chrome has an issue with the same thing. If you're serving these big images, it basically starts to just kill the whole thing. The whole page kind of implodes. So there's a scrolling hit here as well. Now, it's worth noting that this is something that the browsers are going to fix. Paul Lewis from Google did an experiment where he basically did all of the image stuff inside of a JavaScript thing, which don't ever do in production. It was trying to make a point. And you didn't have this scrolling hit. Like the scrolling impact, the scrolling performance was still fluid no matter what you were scaling, which means that the browser's missing out on something. There's some sort of trick that the browser's not pulling right now that it could to improve that. But the reality is that these older browsers and older devices are going to be lingering for a while, so this is still something we have to take into consideration. So not only by sending these large images down or increasing file weight, but we're also impacting the memory, and we're also impacting what the scrolling performance is, which I think it was Etsy, by the way, who came out with the study that showed that their rendering performance, that kind of thing, had a bigger impact than their page load time on their business metrics. So this is something we need to consider as well. So what can we do about it? here's the proposals. There's the picture element, which this was come up by a group of developers, and it's got a lot of support in the developer community. There are detractions against it. There are things people don't like. It's a little verbose. This isn't so bad. We've only got two, basically image sources that we're swapping out. It uses media queries. It was trying to mimic the video behavior. The video element does something like this with sources. But it can get a little cumbersome. You're repeating breakpoints, and it can get really long and obnoxious. But the idea was that by mimicking existing behavior, the thought was that it was going to be easier for browsers. It turns out browsers actually hate this pattern, which was unfortunate. There's a polyfill. I guess you can call it a polyfill. It doesn't exist yet. There is a script that lets you kind of use the same general syntax with empty spans right now. And it looks very, very ugly. But it gets the job done. The script basically is going through and evaluating those media queries and pulling in the correct source. If JavaScript isn't enabled, you get the one that's here in the no script fallback. So it works with no JavaScript. You can swap the images based on resolution. You can swap them based on whether it's a Retina display or a low-quality display. You have art direction abilities. So if you want to make an image like a tighter crop or even a different orientation at a different size, you can easily do that because you're specifying which image source. But again, you're dealing with preloader issues here because it's a script solution. So you're breaking the preloader, which can be troublesome on screen. Like if you have a lot of images on a page, you might notice a big impact there. So you need to kind of evaluate what you're dealing with in terms of what am I gaining for weight, or losing, I guess, in terms of weight, versus what am I losing in terms of what the preloader can offer me here too. There's always that balance. Source set is another one of the proposals, and that looks like this. It's very terse, it's very compact, which has some appeal. It's gotten mixed reviews from some people just because it's not quite as readable. You can see here where they've got the 640W and the 1X. That's with just two things, and then potentially if you had it at height, or like 2 years from now we decided that we needed to know, I don't know, bandwidth or something else that we have in there. The more you add to those things, the more cumbersome that's going to get to read and evaluate. So that has some people who aren't that thrilled about that. But it is nice that it's nice and compact. It works. It plays nicely with the preloader. You can use a polyfill for that as well. And in fact, the resolution side of things, the 2X is basically saying about a Retina resolution. The resolution side of things, that's already there. That already exists in WebKit, so that you can actually do something like that if you want. There's actually a source N, a third proposal that got tossed out. If anybody's seen that, if anybody's paying attention to that stuff yet. There's a source N thing where somebody was, I think it was Tab Atkins, basically said, you know what, he wasn't that crazy about source set, which most of the people involved in the conversation have said that they don't really care for the syntax that much. But they don't like the verbosity of the picture element, so source N was kind of a combination to try and find a happy middle. Basically the reality is that we don't have a solution after 3 years. They're working on different options. There's going to be some solution that's going to arrive, but it's probably not going to happen in the next couple months or anything like that. It's probably going to take a little bit of time to sort it out. It's kind of a complex thing. So these are two things you can do, though. You can do like the polyfill for picture. You can do the polyfill for source set. Guy Pajarni from Akamai has this, he talked about this low-quality image placeholders technique, which is really nice. Basically, back in the day, we used to have the low source attribute where we could declare something that was like a black and white low-quality image that would get loaded, and then that would kind of decrease the weight, and then you have the source that could kick in on top of that. It's basically something like this. You'd basically have the low-quality image display by default, and then using some sort of scripting technique, you'd load in a higher quality image or a bigger image on top of it. What's nice is that this kind of balances it. You get a little bit of the preloader action because the preloader can get this and get this dummy low-quality image onto your display right away as soon as possible. And you also decrease that initial weight, so you've got a little bit of initial performance gain. You are making 2 requests because you're going to double back and bring in that higher resolution thing. So technically, you're increasing overall page weight. But the perception sometimes can be impacted in a very good way, because what the user is seeing is they're seeing an image there, and then hopefully very quickly they're seeing the high quality sit on top of it. Sort of like a progressive JPEG kind of trick there. There's another technique that gets thrown a lot for high resolution displays called compressive images, or as I like to call it, black magic. I have no idea how this works, but it works. I gave a talk at the New York Web Performance Meetup, and I said this about compressive images, and somebody in the crowd actually knew, and she explained everything, and she was getting into everything. It went over my head, and I said, I'm just going to keep calling it black magic until somebody can make me a little animated diagram or something explaining what happens. But the basic idea is that if you take a JPEG and you compress it so that it looks really, really crappy. So like, let's say you're save for web out of Photoshop. Save that thing at like 0 or 10, like a really crappy looking image. But you make it much larger than what it's going to display at. So like 1.5, 2 times the size of what it's actually going to display at in the browser. When the browser shrinks that down, suddenly it looks sharp. And it looks sharp not just on low resolution displays, but on Retina and high resolution displays as well. Black magic. And so the file weight actually tends to be maybe marginally higher or even less than what it would be for the base low resolution, regular, good quality image. So it seems a little too good to be true, which is usually a sign that it is. I haven't seen anybody, I haven't seen anybody dissect it yet to the degree where they've been able to point out exactly what the impacts are. I think there's some memory tests that are going to be done. But you do have to keep in mind it is doing all the sort of things that we just talked about, like that Firefox was having issues with the scaling and the bytes per pixels and stuff like that. But it's a technique that seems to work fairly well for the weight, at least. And we still need to figure out how badly it impacts the other ones. Yeah.
And that's something that we use. Mm-hmm. You find not only often will the size be smaller, the file size will actually be smaller. So,
mm-hmm.
so horrible, so big, but it's actually crisper.
Yeah.
At the smaller size and saving the smaller size at a higher.
Yeah, crisper and yeah. So it's got a lot of visual benefits from that perspective. Obviously, if it's something that if people are going to save the image, if that's something that is a use case off of your site where people could potentially be trying to save the image to their desktop, they're going to get a very crappy looking image. So that's one thing to keep in mind. But it is a way around the weight that can come with trying to serve high resolution displays. So that's so what happens when you're looking at it the full size? Don't look at it at the full size. Don't. It's you remember Indiana Jones where they drank from the wrong cup and then the hair, he turns old and decrepit. That's what happens. Yeah, what you're basically doing. So let's say that you know that your design, your site is your image is never going to scale above 500 pixels. Let's say you would size that image at 750, 800, 1,000 pixels, something like that, something it's never going to render at in the browser, so that whenever it's in the browser will always be shrinking it down. So ideally, from that perspective, living inside the browser, it's never going to be viewed at its full size. So you're never going to see all of its ugliness. Again, that falls apart if people are going to try to save it or things like that, or if they try to take it out of that browser context. But the idea is that within the browser, you make sure that that image never actually displays at its full physical size. Does that answer it kind of? Yeah.
I just thought that you initially were taking the image as it would be, and then compressing it.
No. All right. Yeah. No. So let me explain that again, just in case anybody else caught that. No. So the idea is that if you're displaying the image at 500, 600 pixels, you would normally save it at that, or for resolution, you might double it for the high resolution displays. What the compressive images technique is you take it and you double the size, but then you save it at an extremely low quality so that the file size is really small. And if you look at it full size, you're going to see all these little pixels and all these blurriness and graininess, and it's going to look disgusting. But the browser, when it does its black magic, actually makes it look pretty nice. But again, you are dealing with the extra pixels that we talked about. You are dealing with a lot of the scaling things, so there are things to be watching. The fun stuff with all of this is that basically anything you ever hear in any presentation or read in any blog post is make sure you test it for your situation and on the devices that you're testing on, because your mileage is probably going to vary. depending on the project, depending on the use case. For example, trying to use this compressive image technique on an image that displays at 1,000 pixels doesn't work so well. Like if you create like a 2,000 pixel image that looks really bad, it doesn't seem to have the same impact. Plus, you're talking, even more scaling issues. But just make sure you're testing for your specific situation. Any other questions on that?